Now, let me ask you this. Why do I need to run GRE as a protocol? Why did I have to run GRE as a protocol? What was the purpose? So I could run a routing protocol, right? Because of the tunnel. In the other setup, in the normal crypto map, I could not because it was all based on a policy. There was no direct connection between the two devices. Agreed? So I ended up running a tunnel network. And the tunnel protocol was GRE. What they did about 12, 13 years ago, they said, okay, I see a lot of implementations that they want encryption to be done, and they end up running a dynamic routing protocol with GRE and then running IPSec. Why don't we allow IPSec to be the native protocol on the tunnel interface? What's the default tunnel interface protocol? It is still there. What is it? It's GRE. So I end up running GRE because I need a tunnel interface. But about 12, 13 years ago, Cisco came out and changed, or not changed, allowed you the ability to run IPSec as the protocol on the tunnel interface, as the tunnel protocol, eliminating GRE completely from the picture and being able to run a routing protocol directly between the two sites. This is called a IPSec based tunnel interface. So this is not running GRE at all. It is running IPSec as a protocol. What's the advantage of doing that? Well, if that's the case, I don't need GRE at all. I have completely eliminated GRE from my header. It looks like this, just like a normal IPSec header, no GRE, and I'm running routing. You get my point? So remember earlier on, Mike, you said that the reason I run GRE is because of routing multicast. That is an old, or no, what do you call it? It is a dated document that when you read that IPSec does not support multicast, that's wrong. IPSec does support multicast, but that LAN-to-LAN IPSec does not support it because I don't have a directly connected interface between the two sites. But what if I run tunnel interface and run tunnel as IPSec? So I'm running multicast directly over IPSec, which is absolutely okay. Okay? When I do that, when I eliminate GRE from the header, if I take it out, there's another 8 byte that goes away. So I go from 134 to 126. So my total increase of this packet becomes only 28 bytes, not 52 bytes. So if I'm running a tunnel interface, I want to run this type of interface. This is the native tunnel interface running IPSec. You get my point? So I absolutely can run multicast routing over IPSec as long as I do it over a tunnel interface. I'm not running GRE over there. This is not GRE. This is pure IPSec. Yep, you can call it that. The problem with that, Carl, is when you run BGP between R1 and R2, the packet is still going through the internet. You cannot, the internal route, you can run BGP across it, but the problem with that would be the inside, the internal, the internet would not be able to understand the 10.1, the 10.2, because the data packet is still going through it. So how do I do that? It's a nice concept. I'll just change this to lab number 7. Change the tunnel protocol to IPSec, eliminating GRE completely from the picture. 100%. And I'll show you that right now. How do I do it? Go to the tunnel interface, tunnel mode, IPSec, IPv4, because you can do the same thing for IPv6. Need to do it on both sides. All right, what was the packet size right now? Because I cannot show you the inside. It's 134, right? Let's go ahead and do this. The other thing that I'll do before and after, you guys see? The protocol is being used is what? GRE, right? I'm going to change that. Interface tunnel 1, tunnel mode is IPSec IPv4. It is going to go down until I set the other side up. I eliminate GRE, the protocol, completely from the picture, which will eliminate the 8-byte header for GRE. So I'm now running a normal IPSec protocol with routing over it, just using a tunnel interface. So GRE is not required for a tunnel. I want you guys to understand the tunnel interface, although the default protocol is GRE, it does have the capability of running other protocols. And that's what I just did. I changed the protocol to IPSec. First thing, my routes are back. So my routing is working. But if I check my tunnel interface, it is not a GRE interface anymore. It is what? The tunnel interface is a IPSec tunnel interface. Is disregarded. Very good, because now I don't have duplication. So what should my mode be now for my crypto? It should go back to what? Tunnel, right, Trent? Take a look. I am doing the encryption. I just set it up. It is tunnel. Although my command is set to what? Mode transport. Proof is in the pudding. So this is your proof. Is it clear, guys? New type of IPSec for some of you guys? So this is what we just accomplished. And the size is the last thing I need to show you guys. 126 bytes. To show you that it is completely what? IPSec, yeah. Show tunnel, show interface tunnel. This guy. Pure IPSec. The 8 bytes that are shaved off are those 8 bytes for the GRE header. Any question, guys? All good? Now, just to recap this, what I've done is I've also created this one I did, and I show you the packet size over here. Hello packet with 126 bytes. So you have that in your documentation. But let's say I had to do it from scratch. See, broke it up. I went from GRE, went to GRE IPSec, went to tunnel mode, transport mode, and then went to the native IPSec tunnel, right? What if I had to do it from scratch? Let's say I wanted to do it from scratch. Let's do that as a lab, and then we'll call it lunchtime. Oops. Number 8, configure a native IPSec tunnel interface to connect router 1 and router 2 private networks to each other with encryption. So what I'll do over here is I'll go back and stop my nodes and start it from scratch. Now, if I want to do, if I want to do tunnel-based IPSec from scratch, how do I do it? Let's try the commands for that. 8. Normal IPSec portion. I'll just copy this part because it's going to be the same. R1. If I'm doing a native IPSec tunnel interface, the one that I'm doing from scratch, rather than chopping it up into GRE IPSec, tunnel mode, transport mode, and then going there, I want to do it from scratch. So how would I do it? I do phase 1. And this is going to be pointing to my peer, which is 200.111, public address of the other side. Transform set. I don't need to do mode transport. Why not? Because it's going to be without the duplication of the header. Third step, IPSec profile, crypto, IPSec profile, iprof set the transform set. And number 4, configure the tunnel interface. Because I'm doing it from scratch, I don't have a tunnel interface yet. Interface tunnel 1, IP address, tunnel source, tunnel destination, tunnel mode, and tunnel protection. And last but not the least, routing protocol. (192, 168, 1.1) network 10. That's good enough. This is what your config will look like. Again, phase 1, phase 2, IPSec profile, create the entire tunnel interface. That includes IP address, source destination, change the mode to IPSec IPv4, and enable encryption by using the IPSec profile, attach it to it, and run the routing protocol. Again, still 5 steps. So I'll do this on R1, which is going to be blank right now because I reset it. I don't save my config, so I have a base config. So all my config remains the same. I don't save the config in the middle of my lab, so I can revert back. So it's blank right now. Once, what I do, Trent, is you go in, you configure the routers with the base IP addresses, save it at that point. Okay? Once I'm done with that, when I restart the routers, after that, I don't really use any of the save commands during the lab. So if I'm not saving it, I stop my routers, they go back to the startup config, just like a normal router. So once you save it, upfront with the IP addresses. All right, so let's paste it. So that's phase 1, phase 2, IPSec profile, tunnel interface, and EdgeRP. Let's go to router 2. Again, should be blank because I saved it up front initially and with just the IP addresses on it. From that point on, I don't save it during the lab. So I can go back and revert back to it. For router 2, same config. The only thing that changes over here is I want to point to 199.111. And this guy, the IP address changes to 1.2. Now source on our router 2 is 200. Destination is 199. The rest is the same. Copy it. Go to router 2. Paste it, and my tunnel should come up. This is a native IPSec tunnel. This tells you that. And what else did I have to show you? Show IP route EIGRP. It's right there. Show crypto IPSec SA. Packets are getting encrypted. Let's send a whole bunch of pings. 10.1.1.1. Source 10.1.2.1. Repeat. Let's set 1,000 packets. What is the source? Taxi or whatever that is. Show crypto IPSec SA. There you go. Bigger number. Good, everybody?